All right, buckle up, everyone, because in this deep dive, we're asking that big question. What's next for humanity beyond Earth? We're exploring Michio Kaku's The Future of Humanity.
It's an amazing book, really diving into what our future amongst the stars might look like, drawing on all these insights from top scientists.
Yeah, and we're going to pull out the most mind-blowing stuff, the things that make you go, hold on, we could really do that.
Right. But, Kaku starts off with something pretty sobering. 99.9% of all species that ever lived on Earth have gone extinct.
Whoa, okay, starting off strong. I mean, that puts things in perspective for sure.
It does, yeah. And he talks about all these threats, supervolcanoes, asteroids, even, things we do to ourselves, like messing up the environment or weaponized microbes.
Okay, getting a little nervous now. But Kaku isn't just doom and gloom, right?
Exactly. He says becoming a spacefaring species is less about sci-fi fantasies and more about, well, survival long term.
So less Star Wars, more like life insurance for humanity.
Exactly. And to understand how we might get there, he takes us through the history of rocketry. And it's really a story that unfolds in phases.
Oh, this is cool. Lay it on me. Where does it all begin?
Long before rockets even existed, there were the dreamers, like this guy, Konstantin Tsiolkovsky, a Russian school teacher, late 1800s.
School teacher?
Yeah. And he figured out Earth's escape velocity, the speed you need to break free from gravity, before rockets were even a thing.
No way. Just using, like, math and physics.
Pretty much. Devouring science journals, even though he was, struggling financially. Tsiolkovsky really believed our destiny was out there in space.
Talk about a visionary. But dreams need to become reality, right?
Right, that's where the builders come in. Think Robert Goddard, early 1900s, American, perfecting liquid-fueled rockets.
Pushing the boundaries, huh? I feel like early rocket scientists didn't get much respect back then.
Oh, yeah. The New York Times even made fun of Goddard's ideas. Said rockets couldn't work in a vacuum.
Oh, man, classic.
The funny part is they had to retract that statement after we landed on the moon.
Yeah, how about that? So we've got dreamers, builders, and then what really launches us into the space age?
Governments. They realize, hey, this rocket stuff is powerful, could be useful.
Right, the military applications and the whole space race thing, right?
Yeah, and the big name here is Wernher von Braun. Basically, Immustar rocket science.
Von Braun. Man, what a story, huh? From what, aristocratic beginnings to working on the Nazi rocket program to leading Apollo in the U.S., it's wild.
It is. Like, even as a kid, he was obsessed with rockets. There's this story about him strapping fireworks to a toy wagon, sending it flying through the streets of Berlin.
No kidding. I guess you could say that was foreshadowing. So what's the key takeaway from all this evolution of rocketry?
What's fascinating is how each phase was crucial. You couldn't have had the builders without those dreamers to inspire them, right? And government programs wouldn't have happened without the groundwork laid by those early builders. It all led up to that iconic moment. Apollo 11 on the moon.
Yeah, that was huge. Like, humanity actually achieved the impossible. But the story doesn't end there, does it?
Nope. There was a bit of a lull after Apollo, but then, bam, this new wave comes along, driven by private companies like SpaceX, Blue Origin, all those.
It's like the new space race,
Yeah.
only now it's billionaires with a vision, like Elon Musk and Jeff Bezos. That's a pretty big shift, isn't it? From government run to these private ventures driven by, well, profit and this passion for exploration.
Definitely a shift. You've got NASA focused on safety and all that, so they have to move slower. Then you've got these private companies, much faster, more risk-taking, just iterating quickly.
So more like the Silicon Valley approach. Move fast and break things, but in space.
Yeah, kind of. And it's creating this competition. Everyone's got their eye on Mars.
Mars is definitely the hot ticket these days. But before we get to that, Kaku talks about the moon being this important stepping stone, like a launch pad.
Yeah, and not just for missions, but for resources, too. He highlights all this economic potential, which is fascinating.
Okay, tell me about this lunar gold rush. What are we talking about here?
Well, not gold exactly, but resources that could change everything, like water ice found in those permanently shadowed craters that could be used for rocket fuel, drinking water, even farming.
A lunar gas station and farm. That's wild.
Right. Then there's helium-3, potential fuel for future fusion reactors. Fusion, by the way, is that process where you smash atoms together and release tons of energy.
Fusion? So we're talking about solving Earth's energy crisis by tapping into the moon.
It's a possibility, yeah.
Yeah.
And then there's rare earth elements, crucial for all our electronics. Mining those on the moon could take the pressure off Earth's resources.
So moon bases, lunar mining, clean energy. This is starting to feel like a sci-fi movie,
Yeah.
but what about actually living on other planets? Mars is calling, right?
Before we get to Mars, Kaku takes us on a little detour.
Asteroids.
Asteroids. Okay, I'm intrigued. What's the deal with those giant rocks? They're packed with valuable stuff. Metals, resources, some even rarer than gold. Imagine if platinum, which is used in everything, became super abundant because we are mining asteroids.
I'm picturing a space-age gold rush. People staking claims on asteroids, giant mining ships.
It's a captivating idea, right?
Yeah.
But ultimately, the draw of Mars, actually setting foot and living on another planet, is powerful.
All right, let's dive into that then. What are the biggest hurdles to actually living on Mars?
Well, the low gravity is a big one. It could lead to muscle and bone loss, so Martian colonists would need to be super fit, always working out.
Martian gyms, zero-gravity yoga, I can see it now.
And then there's the thin atmosphere, means you need pressurized habitats, but it also means a 100-mile-per-hour wind would feel like a gentle breeze.
Whoa, that's crazy. What about the radiation, though? Isn't that a big concern?
It is, but Kaku says the risk increase isn't as dramatic as some people think. Of course, there's the psychological strain, too, being so far from Earth, the isolation. Like in that movie, The Martian.
Yeah, Matt Damon all alone growing potatoes, having to be super resourceful. So Mars is challenging, but it's got that allure, that pull.
Yeah, it does. And Kaku points out some of the amazing things Mars offers.
Give me the Martian tourism pitch. What are the must-sees?
Okay, well, you've got to see Olympus Mons, the biggest volcano in the solar system, 2.5 times taller than Mount Everest.
Whoa, okay, that's on the list. What else?
The geology is incredible. So different from Earth. Ice, snow, dust, dunes, creating formations unlike anything we've ever seen. Imagine hiking through that, landscapes no human has ever touched.
That's amazing.
Yeah.
But any chance life was ever on Mars?
What's fascinating is, even though it's so different from Earth, there is evidence that liquid water flowed on Mars billions of years ago. Some scientists even think life might have started on Mars and then, hitched a ride to Earth on a meteorite.
Whoa, mind blown. That raises so many questions. So, moon bases, asteroid mines, Martian outposts. Where does Kaku take us next on this journey beyond Earth?
He goes into this really ambitious, maybe even controversial idea. Terraforming Mars, turning it into a more Earth-like planet.
Terraforming, like literally changing a whole planet. How is that even possible?
It sounds crazy, but Kaku gets into the science,
Yeah.
the potential steps involved. It all starts with warming the planet up.
I'm picturing giant space heaters, but I'm guessing it's a bit more complicated.
A bit. One idea is to inject greenhouse gases into the Martian atmosphere. Those gases trap heat, so it slowly warm the planet up.
So like a planetary greenhouse effect?
Yeah. There's also this idea of using giant mirrors in space to focus sunlight onto the Martian ice caps, melting them faster.
Space mirrors. Okay, so we've cranked up the heat. What's next?
Next, you need a breathable atmosphere, right?
Right.
So that means introducing oxygen-producing plants and bacteria.
So we're talking about cultivating a whole biosphere on Mars. Sounds like a huge task.
Huge, yeah. But scientists are already experimenting with greenhouses that simulate Martian conditions, seeing what can grow.
That's cool. It's like we'd be planetary gardeners seeding a whole new world. But wouldn't that take, like, centuries for plants to make enough oxygen for us to breathe?
Yeah, the time scale for terraforming is huge, EE. We're talking centuries, maybe even millennia.
Wow, that raises some big questions. I mean, if it takes that long, how do we ensure that the project continues generation after generation?
That's one of the really thought-provoking things Kaku brings up. It's not just about the science. It's about long-term vision, commitment, even changing how we think about time itself.
Yeah, it's mind-blowing to think on those timescales. Okay, but before we get too philosophical, let's get back to interstellar travel. Even if we terraform Mars, reaching other star systems is a whole other challenge, right?
Definitely. The distances are just insane. Even with super advanced engines like fusion drives, which are still theoretical, it could take centuries to reach the closest stars.
That's where those ideas of generation ships, suspended animation, extending lifespans come in, right? Each with its own, like, wild implications.
Exactly. Kaku goes into all those possibilities, the science, but also the big ethical questions they raise.
Okay, I am ready for part 2 of this deep dive.
Welcome back to our deep dives into humanity's future beyond Earth. Last time, we were talking about terraforming Mars, turning it from, like, this cold, dead planet into a potential second home.
Yeah, terraforming, it's such a massive idea. I'm still trying to grasp the sheer scale of it.
It's mind-boggling for sure. We were talking about those early stages warming Mars up and creating an atmosphere, but I'm curious about how that would actually work.
Yeah, me too. We talked about using greenhouse gases and space mirrors to warm things up, but how do you go from that to an atmosphere humans can actually breathe?
That's where things get really interesting. We're talking about introducing life to Mars, or specifically
Mhm.
oxygen-producing plants and bacteria.
Whoa, so like giant greenhouses stretching across the Martian landscape.
It's a cool vision, right?
Hmm.
And it's not as sci-fi as it sounds. Scientists are already doing experiments here on Earth, simulating Martian conditions, seeing which organisms could survive there.
So it's not just about taking Earth plants and hoping they grow on Mars. We'd need to select or maybe even engineer life specifically for that environment.
Exactly. It's a delicate balance, finding organisms that can not only survive, but also create a stable ecosystem, something self-sustaining.
That makes me think about the ethical side of things. Are we playing God by bringing Earth life to another planet? What if it backfires? Could we accidentally create an ecological disaster on Mars?
Those are really important questions, and Kaku acknowledges the potential risks. It wouldn't be a decision to take lightly, and it'd need constant monitoring to make sure we're not causing unintended harm.
It's mind-blowing to think about the long-term consequences, right? We're not just changing a planet, we're potentially shaping the future of life on a whole other world.
It's humbling, for sure. But okay, let's shift gears a bit. What about getting to those other star systems? Even if we terraform Mars, interstellar travel is a whole different challenge.
Yeah, the distances are just insane. We touched on that earlier. But even with advanced engines like fusion drives, it could take centuries to reach the nearest star.
Exactly. And that's where Kaku digs into those three options.
Yeah.
Generation ships, suspended animation, and extending human lifespans. Each one is like a potential solution, but they all come with these crazy complexities and ethical dilemmas.
Let's start with generation ships. I'm picturing these massive arcs carrying thousands of people on a journey that could take, like, multiple generations.
Yeah, it'd be like creating a self-contained mini-civilization,
Yeah.
hurtling through space.
The logistics are mind-boggling. You'd need to create a whole ecosystem on board, grow food, recycle everything, provide healthcare, education.
Not to mention the social dynamics. Can you imagine trying to maintain a society over generations all cooped up in a spaceship? The potential for conflict, the psychological impact.
Yeah, it'd be like a pressure cooker in space. But even if we could figure out those social and logistical challenges, wouldn't we need some kind of crazy new engine to make interstellar travel possible within a human lifespan?
Definitely. Kaku talks about theoretical engines, like fusion drives, which would use nuclear fusion for thrust, or even antimatter drives, using the annihilation of matter and antimatter for energy.
Antimatter drives. That sounds like pure science fiction. Are those even remotely possible?
Well, the science behind them is sound, but the engineering challenges are, like, off the charts. We're talking about pushing the very limits of our technology, so it's hard to say when or even if they'll become reality.
Okay, so maybe not anytime soon. What about suspended animation? Could we just put ourselves to sleep for centuries and wake up at our destination?
It's a tempting idea, right? Like in those sci-fi movies. Slow down your metabolism, basically put your body on hold for the whole trip.
It sounds convenient, but are there risks? What if something goes wrong while you're, in suspended animation? What about the ethical side of it?
There are definitely challenges. The technology isn't there yet, and we don't know the long-term effects on the human body. Plus, imagine waking up centuries later on a completely alien planet, cut off from everything you know.
Yeah, that's a heavy thought. Okay, so let's say we could overcome all those hurdles. Would suspended animation even be practical for large-scale space colonization?
That's another question Kaku brings up. Even if it was safe, the logistics of transporting and reviving thousands or even millions of people would be incredibly complex.
So each option has its own trade-offs, its own set of problems. Does Kaku have a favorite, like the one he thinks is most likely to work?
He doesn't really pick a winner. He presents them all as possibilities, each with its advantages and disadvantages. It's more about us, as a species, deciding which path we want to take, which risks we're willing to accept.
It's exciting and terrifying at the same time, realizing we have the potential to choose our own destiny in space. Okay, but before we get lost in the how, let's talk about the why. Are we even alone out there? Is there other intelligent life in the universe?
Now you're asking the big question. And it's one that Kaku really dives into, exploring not just the search for aliens, but the very nature of intelligence itself.
All right, I'm ready for some alien talk.
UFOs.
Signals from space, the works.
Well, Kaku's approach is a bit more grounded in science and logic, But he doesn't shy away from the possibilities. He takes us through the history of SETI, the search for extraterrestrial intelligence, all the different ways we've tried to listen for signals.
SETI, it's like we're casting a giant net across the cosmos, hoping to snag something truly extraordinary. But if there are other intelligent civilizations out there, why haven't we found them yet? That's the Fermi paradox, right?
Exactly. And it's a puzzle that hangs over this whole search for alien life. If the universe is teeming with life, why haven't we found any solid evidence yet?
It's a mystery that spawned all sorts of theories. What are some of the explanations Kaku explores?
He looks at a whole range of possibilities. Maybe advanced civilizations are intentionally hiding from us, or maybe they visited Earth long ago, leaving clues we haven't figured out yet.
I'm getting chills just thinking about it. It's like we're living in a cosmic detective story, searching for clues to a mystery that could change everything we know about our place in the universe.
It's a captivating thought, isn't it? Kaku also considers the possibility that we're just too primitive to detect them. Maybe their technology is so advanced, it's basically invisible to us.
So we're like ants crawling on the sidewalk, oblivious to the city around us.
Yeah, kind of. It shows how limited our understanding of the universe still is. We might be looking in the wrong places, using the wrong methods.
It's humbling, but it also makes the search even more exciting. What if we're right on the cusp of a discovery that could change everything?
It's a thrilling prospect. And it's something Kaku leaves us pondering as we go even deeper into the implications of humanity's future beyond Earth.
Welcome back to the deep dive. We're in the final stretch of our exploration of humanity's destiny beyond Earth. And last time, we were grappling with that huge question: are we alone in the universe?
It's a question that's fascinated us for, well, forever. And as we continue with Michio Kaku's The Future of Humanity, we find that the search for alien intelligence isn't just about finding aliens. It's about understanding what intelligence even on.
That's a really interesting way to put it. So where do we even begin to untangle that mystery? We talked about the Fermi paradox, the idea that if intelligent life is common, why haven't we met anyone yet? What does Kaku say about that?
Well, he suggests that to figure out where to look for intelligent life, we need to understand what makes intelligence possible in the first place. He lays out 3 key criteria that he thinks are crucial.
Okay, I'm all ears. What are these 3 essential ingredients for intelligence?
First, you got to have stereoscopic vision. That's the ability to see depth and distance. Think about predators hunting or even just navigating a complex environment.
Right, makes sense. We humans use depth perception all the time, driving, playing sports, you name it. Hard to imagine being intelligent without that spatial awareness.
Exactly. And the second thing you need is some kind of grasping appendage.
Like hands, essential for tools, building, pretty much everything we do.
Yeah. Doesn't have to be hands specifically. It could be tentacles, claws, anything that lets you manipulate objects, interact with the world in a precise way.
So we're not just looking for brainy creatures. We're looking for ones that can actually shape their environment, build things, create.
Right. And the third essential ingredient is language.
Ah, language. The ability to communicate ideas, pass on knowledge to the next generation. Seems pretty fundamental for any civilization to advance.
Absolutely. Without language, knowledge is stuck with an individual. There's no way to build on the past, create complex societies, all that.
So thinking about those 3 criteria, are there any other species on Earth besides us that come close?
It's a cool question, and Kaku uses some interesting examples. He talks about dinosaurs, how they were dominant for millions of years but never developed intelligence.
Dinosaurs. Seriously, I always thought they were pretty impressive in their own way.
Oh, they were powerful, successful, but they lacked one key ingredient: grasping appendages. They couldn't manipulate their environment in a sophisticated way.
So even with their size and strength, they couldn't build tools, make art, develop technology. It makes you wonder, what if dinosaurs HAD evolved differently? Could they have built a civilization?
That's the kind of thought experiment Kaku gets us thinking about. He also talks about octopi. They're known to be very intelligent.
Octopi, those 8-armed creatures that can squeeze through anything and change color, what makes them so smart?
They're amazing problem solvers. They learn quickly, and they've even been observed using tools.
So they've got the stereoscopic vision, the grasping appendages. But what about language? Can they communicate complex ideas?
That's where they fall short. They don't have a sophisticated language system to pass knowledge down through generations.
So close, yet so far. It really highlights how powerful language has been for us humans, hasn't it? It's allowed us to build everything we have.
It's a game changer, for sure.
It,
But okay, let's talk about the Kardashev scale for a minute.
yeah.
That's the one that measures a civilization's level of technological advancement based on its energy use, right? Where do we humans fall on that scale?
We're like toddlers in the cosmic playground. I think we're still considered a type 0 civilization, which means we're mostly reliant on fossil fuels and stuff.
Yeah, still in our energy infancy, so to speak. But we're getting close to becoming a Type I civilization, which means harnessing all the energy that falls on our planet from the sun.
Wow, that sounds like a major upgrade. What would it take to get there?
Kaku talks about shifting to renewable energy, solar, wind, geothermal, also developing new technologies like fusion power, which could be a game changer.
Clean, abundant energy for everyone. It's a future worth fighting for, isn't it?
It is. And becoming a Type I civilization would be huge, not just for technology, but for how we see ourselves in the universe. We'd go from a species stuck on one planet to one that can harness the power of a star.
It's mind-blowing to think about, but Kaku also warns us about the dangers, the things that could stop us from reaching our full potential as a spacefaring species.
Right, he talks about things like nuclear proliferation, the spread of nuclear weapons, which could be disastrous.
It's a sobering thought. We could end up destroying ourselves before we even get the chance to reach for the stars.
It's a possibility we can't ignore. And then there's climate change. If we don't address it, rising sea levels and extreme weather could make space exploration seem like a luxury we can't afford.
It shows how interconnected everything is, right? Our future on Earth and our future in space are tied together. We need to solve the problems here if we want to have any chance of venturing out there.
Absolutely. And there's also the potential risks of artificial intelligence. As AI gets more powerful, we need to make sure it stays under human control, that it aligns with our values.
That's like a classic sci-fi trope, right? AI turning against its creators. It's
Yeah.
something we need to be really careful about as we develop these powerful technologies.
Kaku stresses the importance of ethics in AI development, making sure we're using it for good, not creating something that could threaten our existence.
It's a lot to consider, all these possibilities and dangers, but even with all the challenges, Kaku seems optimistic about our potential as a species.
Yeah, he believes we have the ingenuity, the resilience, the drive to overcome these obstacles and create a positive future for ourselves among the stars.
It's inspiring, to think we might be on the cusp of a whole new era of exploration and discovery, where we break free from our earthly limitations and become a truly spacefaring civilization.
It's an incredible vision, but it's clear that the journey won't be easy. We'll need to face our flaws, solve incredibly complex problems, and work together as a species to reach that goal.
That's a powerful message and a fitting one as we wrap up our deep dive into Michio Kaku's The Future of Humanity.
It's been an amazing journey, exploring all these ideas, from terraforming Mars to searching for alien intelligence. It leaves you with a sense of awe, doesn't it? The vastness of the universe, the incredible potential of humanity.
It really does. So as we sign off, what's the one thing you hope our listeners will take away from this deep dive?
I hope they come away with a sense of wonder, of possibility, and a sense of responsibility, too. The future is out there, waiting for us to shape it. But it's up to us to decide what kind of future we want to create.
Well said. Thanks for taking us on this incredible journey through Kaku's vision of the future. It's been an absolute blast.
The pleasure was all mine.
And to everyone listening, thank you for joining us on the deep dive. Keep looking up at the stars, keep asking the big questions, and never stop exploring the wonders of the universe. Until next time.